All right, hello everyone. My name is Michael, and we're going to be looking at problem 7 from the target round of test release 12503, which was our high school test for the month of December 2024. So with that, let's go ahead and get started. A right triangle with integer side lengths has a leg of length 112. Compute the sum of all possible lengths of the triangle's other leg. So we're going to have this fun right triangle guy over here, and we know that one of the lengths is legs is 112. The other one, we'll call it x, and the hypotenuse, let's say, has length y. Now note that 112 is not necessarily less than or greater than x. It's certainly not equal to, because that would be a 1, 1, root 2 triangle. So this is not necessarily to scale, but it helps us visualize. So by the Pythagorean theorem, we know that 112 squared plus x squared equals y squared. So that means that y squared minus x squared, which is equal to y plus x times y minus x by the difference of squares, has to equal 112 squared. Now, what can we note here? We know that x and y are integers, right? So if x and y are integers, then their sum and their difference, in other words, y plus x and y minus x, need to have the same parity. In other words, they need to be both even or both odd. Because say if x and y is one odd and one even, then we're going to end up their sum and their difference are both odd. If they're both if x and y are both even, or if they're both odd, then their sum and their difference will both be even. Now, why is that helpful? We know that the product of the sum of x and y and the difference, the positive difference between x and y minus x, needs to be 112 squared. 112 squared is even. So that means that y plus x and y minus x are both even. Now, why is that helpful to us? That's helpful to us because we can use this as a substitution. We can now say, right, let's say that we have s, let's let s equal y minus x over 2, and let's let t, right, equal y plus x over 2. Then that means that s times t is going to be y minus x times y plus x over 2 squared. So that's 56 squared, right, 112 squared over 2 squared. And we also know that if I have, let's see, we're looking for x. So x is going to be equal to t minus s. Yep, t minus s. So we know both of these things, right? So we are trying to look for all of the possible values of x. Now, using this equation over here, we can see that x, right, is just the difference between the members of the factor pairs of 56 squared, right? So let's say we have 56 squared and 1, then one possible value of x is therefore going to be 56 squared minus 1. Now, note that x has to be greater than 0. X has to be a positive integer because it represents a side length. So therefore, s is strictly less than t. So we're trying to look for, over all factor pairs that are not 56 times 56, the difference between the two elements of the factor pair, right? So we're looking for over all possible factors of 56 squared. We want the difference in each factor pair to be greater and the smaller one. Now, how do we do this? Well, we can first find the sum of all of the factors of 56 squared, right? So we know that 56 squared is equal to 2 to the times 7, 2 to the 6th times 7 squared. So that means that by the formula for the sum of the factors, that'll be 2 to the 0 plus 2 to the 1 plus 2 to the 2, all the way up to 2 to the 6th times 7 to the 0 plus 7 to the 1 plus 7 to the 2. So that's the sum of all of the factors of 56 squared. But we need to find the sum of all of the differences in each factor pair of two distinct factors. So this lists all of the factors once. The first thing we need to do is subtract 56, right? 56 shows up in there. 56 is not involved in any of these factor pairs since x can't equal 0, so we subtract 56. The next thing we need to do is subtract all of the factors of 56 squared that are less than 56 twice. And the reason we have to subtract it twice is one time we have to subtract it because, well, it's not the larger number in the pair. And the second time we have to subtract it because we're finding the difference between the elements of the pair. So we're subtracting it to get that difference. The factors of 56 squared that are less than 56 are 1, 2, 4, 7, 8, 14, 16, 28, 32 and 49. And we can check that that's correct. 7 times 3 is 21. Yep. Because 56 squared has 6 plus 1 times 2 plus 1. 7 times 3 is 21 positive divisors. Since it's a perfect square, one of them is its square root, 56. There are 10 less than 56, 10 greater than 56. There are 10 here. So that means that we can compute our final desired sum of all possible lengths of the triangle's other leg, which is the sum of all possible values of x, which is going to be 127 times 57 minus 56 minus 2 times, those will sum to 161. And if you calculate this out, you will get 6,861. And that is our answer to problem 7 of this target round.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.